Today I would like to show you where the quadratic formula actually comes from. So we've been using this thing called the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. We've been using this thing to help us find zeros and to solve quadratic equations, to find those x-intercepts, to find those roots. But where in the world does this thing even come from? Why does it work? How does it work? So today I'm going to show you that, where this formula comes from. So to do that, we're actually going to take the equation ax squared plus bx plus c equals 0, and we're going to solve for x by completing the square. So in this equation, we are going to solve for x. We're going to find what is x equal to in this equation. And hopefully, if we do this right, we'll end up with the quadratic formula. So how does this work? Well, if I want to solve this equation by completing the square, remember we need to isolate the first two terms. So we need to isolate the ax squared term and the bx term. To do that, we're going to move the positive c to the other side. So we're actually going to start by just subtracting c to the other side. So we get ax squared plus bx is equal to negative c. Okay, so now we're ready for the next step to solve by completing the square. So when we complete the square, we actually want our coefficient of the x squared term to be equal to 1. So how can I make ax squared be 1x squared? What would I have to do to get rid of this a? Well, I'm actually going to have to divide the whole equation by a. So we're going to have to divide this by a, this by a, and this by a as well. So ax squared divided by a simplifies to x squared plus bx divided by a. Unfortunately, we're just going to have to deal with a fraction now. B over a x is equal to, and then negative c over a, we're just going to have to deal with a fraction. But that's okay. We're in high school. We're not afraid of fractions anymore. From there, I'm ready to find what I need to add to both sides here to complete the square. So in order to do that, remember we have to take this coefficient, we have to divide it by 2, and we have to square it. So we're going to take b over a, I'm going to do that off to the side here, b over a, we're going to divide it by 2 and then square it. So when I divide a fraction, I can actually change this to b over a divided by 2. And I can change this division to multiplication if I flip the second fraction. So this is technically 2 over 1. I'm just going to flip it to be 1 over 2. So now b times 1 is b, a times 2 is 2a, and then we're going to square it. So when I square this, I'm going to have b squared over, and then 2a squared is 4a squared. Remember, you have to square the 2 and the a. So that means to complete the square, we're actually going to have to add b squared over 4a squared to both sides of this equation. So we're going to take this equation and we're going to add b squared over 4a squared. And we're going to add it to both sides to be fair. What we do to one side, we have to do to the other. Okay. Then, as we continue, to be able to solve by completing the square, we need to factor the left side. So to factor the left side, and just to be like the quadratic formula on the right side here, I'm going to put the b out in front. So this is going to be b squared over 4a squared minus c over a. I just flip-flopped the order there. Okay. So to factor this, I know I want x times x to get me x squared. And then I need something times something to get me b squared. So b times b will get me b squared over, and then 2a times 2a, wouldn't that get us 4a squared here? So 2a times 2a would be 4a squared. And then we need a positive, or actually, yeah, we need both of them to be positive. Okay, so these are the exact same thing, so I can rewrite them as x plus b over 2a squared equals, now on the right side here, we need to go ahead and just make our lives easier by subtracting these two fractions. So trust me, we're going to want to subtract these two fractions. To be able to do that, though, we need a common denominator. So for my common denominator, this one has 4a squared and this one has a. So I'm going to make 4a squared my common denominator. Well, what is this fraction missing? This fraction is missing the 4 and the a squared part, right? Which means I need to multiply the top and the bottom by 4a. So we have b squared over 4a squared minus c times 4a is 4ac all over, and then 4a times a is 4a squared. 4a squared. Hey, 4ac reminds me of the quadratic formula. I wonder if we're on the right track. That sounds like good news. Okay, so we have x plus b over 2a squared equals, now that these two fractions have the same common denominator, we can go ahead and combine them into one fraction. So we're going to have b squared minus 4ac all over 4a squared. Hey, b squared minus 4ac. Isn't that somewhere in the quadratic formula? Check it out. We found a piece of the quadratic formula. Interesting. Okay, let's keep going. So x plus b over 2a squared. We're still trying to solve for x, remember? How am I going to get x out from being squared? Well, to cancel a square, I have to square root both sides. So that square root cancels the square, and we're left with x plus b over 2a is equal to, now over here, we have the square root of a fraction. So to make our lives easier, we're going to square root the numerator, and we're going to square root the denominator. When I square root both sides of an equation, how many solutions does that give me? It gives me 2, plus or minus. So let's simplify this denominator here. So I have x plus b over 2a is equal to plus or minus the square root of b squared minus 4ac all over. Now, what's the square root of 4? 2. What's the square root of a squared? A. Now, we are ready to solve for x completely. So we still want to get x by itself. To do that, we're going to subtract the b over 2a to both sides. I'm going to come up here. So x is equal to b over 2a minus itself cancels. And then on this side, the right side, we're going to have negative b over 2a plus or minus I did not leave myself enough room to write this, so I am going to actually make my pen smaller and write smaller. So x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac, all in that's over 2a. Well, hey, don't these fractions have the same denominator? So couldn't I go ahead and combine them into one fraction? So x is equal to, I'm going to combine them into one fraction with the denominator of 2a. And then that means the numerators get combined, so negative b plus or minus the square root of b squared minus 4ac. And hey, check it out. We have the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So I have a challenge problem for you. And this challenge problem is totally optional. I want you to do the exact same steps that we just did, except this time you're going to solve for z. So you have 0 equals az squared plus bz plus c. Exact same equation, different variable, solve for z. And you're going to do the exact same steps we just did in our notes of solving for x to derive that quadratic formula. And you should get the exact same answer, except this time it's z equals that. Give it a shot. See if you can find it. But it's totally optional, so I won't grade whether or not it's in your notes. But I would love to see it in your notes. Surprise me. Just try. See how far you can get. All right. Have a good week.